Good morning students. Today's class will discuss about what is basic logic gates. Last class we have explained the evaluation of a Boolean expression. Today's class will discuss what is logic gates. Logic gates is nothing but it's an electronic circuit which operates on one or more input signals and produces an output signal. See, logic gates is nothing but it's an electronic circuit which going to operates on one or more input signals but produces an output signal. There are three types of logic gate. First one is NOT gate. Second one is OR gate. Third one is AND gate. We will discuss one by one. First one is NOT gate. This NOT gate is also called as the inverter gate. The NOT gate is also called as the inverter gate. NOT gate is going to operate on only one input signal and produces one output signal. The output, whatever it is produced, it is nothing but your complement of your input or inverse of your input. So the name it is inverter gate. The inverter gate, the name means it is always the output produces is always a complement of your input gate. So input signal. So NOT gate accepts one input signal and produces one output signal. The output signal, whatever it is being produced, that is always a complement of your input signal. So this NOT gate is also called as the inverter gate. The symbol of your NOT gate is, so if it accepts one input signal, let the input signal be X. The output will be the X bar. Suppose the signal, whatever input you have given, X is 0, that is low voltage. Low means the output will be high. If you have given high means the output will be 0. So this is nothing but your NOT gate. Second one is your OR gate. This OR gate is going to operate more than two input signal but produces only one output signal. And whatever the output it is being obtained, it performs a logical addition of the inputs. It performs a logical addition to the inputs. That is nothing but your OR gate. OR gate is nothing but it takes more than two input signals but produces one output signal. Whatever the output is performs is nothing but it's a logical addition of your on the input signal. So here the symbol of your OR gate is this is the two input OR gate. This is for two input OR gate. Next one, this is for your three input OR gate. Three input OR gate. This one is your four input OR gate. So it is going to perform the output is nothing but whatever obtained output, it is nothing but performs a logical addition on your inputs. So I have already explained in the last class A, B for two input 0, 0, 0, 1, 1, 0, 1, 1. That is 1, 2. I have already explained 0, 1, 2, 3 for two inputs 0, 0, 0, 0, 1, 1, 0, 1, 1. So the output will be A plus B. That is nothing but your result R. 0, 1, 1, 1. This is for your two input signal. Suppose if you want to go for the three input signal, so three input signal of your OR gate is you are going to 2 to the power of 3. That is nothing but 8 possible ways. So 0, 1, 2, 3, 4, 5, 6, 7 representation, that is your 8. And you take the 2's multiple, 1, 2's are 2's are 4. Now in place of 0, 0, 0, 0, 0, 0, 1. In place of 2, 1, 0, 0, 3, 0, 1, 1, 1, 0, 0, 1, 0, Clearly, either goes in the two multiple, always partition of the input possible ways, divide by half by, again partition into half, again partition into. So this is one. The result R is nothing but A plus B plus C. So 0, 1, 1, 1, 1, 1, 1, 1. In a logical addition, you are going to perform. If in the case if input is all the condition, all the input signal is 0, the output will be 0. If any one input is high, automatically the output will be high. This is for your 3 input of your OR gate. This is 3 input of your OR gate. Next we'll see your third logic gate is your AND gate. Here this AND gate is also going to operate on more than 2 input signal but produces a 1 output signal. The output signal is nothing but which is going to perform a logical multiplication of the input signals. So that is nothing but your AND gate. The symbol used for your AND gate is for 2 input is A, B. The symbol used. This is nothing but R is the result. We are going to perform A into B. The logical multiplication is being performed. This is for 2 input AND gate. And this is for 3 input AND gate. So this is of your 2 input AND gate. You are going to take the 2 input signal A and B. R is nothing but your result, that is nothing but A into B, that is nothing but A dot B is nothing but logical multiplication. Next, this is 3 input AND gate. You are going to perform, you are going to take 3 inputs A, B, C, and R is the result, that is nothing but logical multiplication of A input, B into B input into C input. This is the 4 input AND gate. This is the 4 input AND gate. You are going to perform, you are going to accept the 4 inputs A, B, C, D. R is the result of logical multiplication of the inputs of A, B, C and D. So this is the truth table of your logical multiplication of 2 input. So I have already explained how to place your zeros and ones for 2 input. So in logical multiplication, if both the input is high, both the signal is high, the output signal will be high. If any one signal is low, that is 0, means the output signal will be 0. Here, see 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0. If both the input or both the signal is high, the output signal will be high. This is for 2 input logical multiplication. For 3 input logical multiplication or AND gate is, you people know how to represent 3 input. Again go for 2's multiple and replace 8 possible ways. 0, 0, 0. For in place of 1, place 1. In place of 2, place 1. In place of 3, that is 2 plus 1 is nothing but 3. 3. 4, 1, 0, 0. 5, 4 plus 1 is nothing but 5. 4 plus 1 is 5. 6, 4 plus 2 is nothing but 6. 4 plus 2 is in place of 4 and 2, you are going to highlight with 1. That is your high signal. Then 0 is your low. Next, 4 plus 2 plus 1 is nothing but 7. 4 plus 2 plus 1 is nothing but 7. So, you are going to perform a logical multiplication on your ABC. The result obtained is 0. 0 into 0 into 0 is 0. 0 into 0 into 1 is 0. So, 0 into 1 into 0 is 0. 0 into 1 into 1 into is nothing but 0. 1 into 0 into 0 is 0. 1 into 0 into 1 is 0. 1 into 1 into 0 is 0. If all the input signal is high, then the output signal will be high. That is nothing but 1. In this case, there are possible values. All the signals, that is A, B, C. It is being high. Then the output signal is 1. So this is about your logic gates. So we have seen what is logic gates. Logic gates is nothing but it's an electronic circuit that will accepts one or more input signal and produces the output signal. There are 3 types of logic gates. One is your NOT gate, second one is your OR gate, and last one is your AND gate. The next topic is basic postulates of Boolean algebra. What is this basic postulate? Basic postulates of Boolean algebra is nothing but the fundamental basic postulates of Boolean algebra. Once again, I am telling the fundamental laws of Boolean. We are taking the fundamental laws of Boolean algebra, and that fundamental laws is also called as the postulates of your Boolean algebra. There are 4 postulates of Boolean algebra. We first one we will discuss. First postulate of Boolean algebra is that if x is not equal to 0, then x should have either 0 or 1. If x is not equal to 0, then x should be 1. And if x is not equal to 1, then x should be 0. So once again I am telling, if x can either be value of 0 and 1. If x is not equal to 0, then automatically x should be 1. If x is not equal to 1, then automatically x should be 0. Next postulate. Second postulate is nothing but your OR relation. You are going to perform your OR operation. That is, you are going to take the rule 0 plus 0 is nothing but 0, 0 plus 1 is nothing but 1, 1 plus 0 is nothing but 1, 1 plus 1 is nothing but. You are going to perform a logical addition on this. The logic gates for 0 plus 0 is nothing but the logic gates of 0 plus 0, logic gate of 0 plus 1, logic gates of 1 plus 0, next logic gate of 1 plus 1. So these are the logic gates and the relation of your OR relation. This is your second postulate. Your third postulate of your Boolean algebra is your AND relation rules. Here I already explained what is the logical multiplication does. If both the input is high, the output is going to be high. So here 0 into 0 is 0, 0 into 1 is nothing but 0, 1 into 0 is 0, 1 into 1 is 1. See, this is nothing but your logic gate of your AND relation. Next, fourth rule is nothing but your complement rule, or fourth postulate of your Boolean algebra is nothing but complement rules. That is nothing but your inverse rule. The output produced is always the opposite of your input. 0 bar becomes 1, 1 bar becomes 0. This is nothing but a logic gate of your complement. That is nothing but your NOT gate. This is the NOT gate of your another. If you do as a one input signal as 0, the output signal will be high. If you do the input signal as 1, the output signal will be 0. This is the nothing but your complementation or inverter rule or complement rule. You are going to use your NOT gate or your inverter gate, and going to perform the operation of the Boolean expression. So these are the 4 rules. First one, if x is not equal to 0, then x should be 1. If x is not equal to 1, then x should be 0. Next rule, your OR relation. Third one is your AND relation. Fourth one is your complement rule. So the next topic is principles of duality. This is very important topic. It carries 2 marks. So this is very important topic. It's going to carry 2 marks. What is this principle of duality? Means in a Boolean relation, okay, you can know this law or this principles of duality. What it states means a Boolean relation, another Boolean relation can be derived by applying these particular rules. What does that mean? Changing each OR sign to an AND sign. Next one, changing each AND sign, that is your OR, to an OR sign. Plus, next changing each 0 by 1 and each 1 by 0. When you apply these rules on one Boolean relation, taking one Boolean relation, you are going to apply the rules or principles of a Boolean relation. The derived relation, get a new Boolean relation. That relation we call as the dual of original expression. We call it as dual of original expression. Once again I am telling principles of duality. What it states means a Boolean relation, within one Boolean relation you can derive another Boolean relation by applying these rules. The derived Boolean relation we call it as the dual of original expression. So you take the, for example, you take one postulate. Take the postulates of your OR relation. 0 plus 0 is nothing but your 0. 0 plus 1 is nothing but 1. 1 plus 0 is nothing but 1. 1 plus 1 is nothing but 1. This is your one relation, one Boolean OR relation. I am going to apply the principles of duality. That is, Next, 0 becomes 1. The plus sign, that is your or, logical or sign becomes your and sign. That is nothing but 0. 1 becomes 0. The relation 1 becomes here it is 0. Now next 1 is changed to 0. The plus is changed to and. 0 becomes 1. The relation here it is 0. Here 1 is changed to 0. Plus is changed to and. Here 1 is changed to 0 and 1 is again changed to 0. This becomes the postulate's third, that is your and relation. So this whatever relation you have obtained, this we called as dual of original expression. Taking one relation and applying the rules or principles of duality, then the obtained relation we called as the, that is the another relation, another Boolean relation that we called as the dual of original expression. What you have done is you took the all postulates, that is the second postulate or relation. I have taken as it is. I am changing each your or sign with your and sign, and each 0 is being replaced by 1. 1 is being replaced by 0. When you change this by applying the principle of duality, you get another expression or another relation that we called as the dual of original expression. That is nothing but your principles of duality. The next topic is basic theorems of Boolean algebra. So how we are going to prove the theorems? We are going to see this particular topic. Here we are going to take the that is the basic postulates of your Boolean algebra is used to define the basic theorems of your Boolean algebra. This basic postulate is going to give all the necessary tools for solving your Boolean expression. Okay, in another way I can say basic theorems can be proved by substituting the possible values of a variable, that is nothing but 0 and 1. Okay, basic theorems can be proved by substituting all the possible values of a variable, that is 0 and 1. This substituting or this proving techniques we called as proof by perfect induction. One more question. What is proof by perfect induction means? It's nothing but by substituting all the possible values of zeros and ones, that we called as the proof by perfect induction. In a Boolean theorems, in the theorems of your Boolean algebra, basic theorems of your Boolean algebra, you are going to substitute the values of zeros and ones in the place of variable either x or y. You are going to substitute the values of zeros and ones. This technique we called as substituting the values of zeros and ones. We call it as proof by perfect induction. There are four properties of your in your basic theorems. First one, properties of zeros and ones. The first property is 0 plus x is equals to x. We are going to prove that 0 plus x is always is equals to x. You can substitute the values of x either 0 and 1. You should get the result as x. First time, this is your LHS, this is your RHS. If x is equals to 0, you consider your LHS. So, that is nothing but 0 plus x. In place of x, you are going to replace it as 0. 0 plus 0 is nothing but 0. Your OR relation. You are performing your, that is you are taking the basic postulates and performing the, proving the theorems. I am taking the OR relation postulates. 0 plus 0 is nothing but your 0. Again, when you consider 0, what is 0 holds here? It is nothing but your x. So, RHS is being proved. For substituting, and what I told, what is basic theorems of Boolean algebra? You are going to substitute the possible values. How you are going to prove this basic theorems? Substituting the values of variables, that is 0 and 1. This technique is nothing but proof by perfect induction. So, I am taking the first properties of zeros and 1. First property is 0 plus x is equals to x. So, I am considering this as LHS, this one is RHS. In place of x, I am going to substitute 0 as well as 1. First condition, if x is equals to 0, you consider LHS. What is LHS? 0 plus x. 0 plus x is nothing but, in place of x, you are going to put in 0. 0 plus 0 is nothing but, you are taking your OR relation. You are considering your OR relation. So, that is nothing but postulate 2. So, 0 plus 0 is nothing but 0. What 0 it in both the conditions same. Only x value changes. First time you are taking 0, second time you are taking 1. 0 plus x is nothing but 0 plus 0 is 0. 0 plus 1 is nothing but 1. So that 0 plus x is nothing but your 0, 1. Then in both the cases, what the output we got the variable x. Properties of 0 plus x is equals to x is the proof. So there are 4 properties of zeros and ones in the Boolean algebra of your basic theorems. First property we have seen 0 plus x is equals to x. The remaining 3 properties will continue in next class. Today I wind up with this particular one of the properties of zeros and one. Next class we will discuss the other 3 topics and some more topics of your Boolean algebra.